Okay, so welcome to Objective 4, the final objective in this lesson about graphing quadratic equations or functions in standard form. And that's exactly what the objective is. Putting all the stuff together that we've talked about so far, and finally graphing the things when they're in standard form. So if you look at the picture there, picture is under a bridge someplace. I think it was some beach. Anyway, but it's made from parabolas. And what you're going to have to do is, of course, graph some of these parabolas by hand. Not just with a calculator, but by hand. So I hope that you kind of like what's going on in this picture, because I'm thinking about making a quiz for you in this unit doing something like this, where you'd have to find yourself a picture, come up with a quadratic equation that made that parabola. I think it's going to be fun. I think it is. Okay. So here are the steps that are involved to graphing a parabola when your quadratic function is in standard form. So the first thing you want to do is determine if you got yourself a beard, your A is positive, or a mustache and your A is negative. Okay? Then you want to find that vertex. The vertex, we're going to use that negative b over 2a. And then stick it back into the equation and find the y-coordinate. And then graph both that and the axis of symmetry. All right? Find your intercepts on number 3. Find your x-intercepts either by factoring or using the quadratic formula or completing the square, whatever your favorite method is. Y-intercept should be pretty easy. It's just c, and you can go ahead and reflect that across the axis of symmetry and get yourself an additional point. Number 4 is only if you need a couple extra points. Plot by guessing and checking. Just plug in a point for x and find out what the y value is. That's only if you need it. All right, let's test our skills on graphing quadratics on this first quadratic equation. Y equals negative x squared plus 6x plus 8. Let me pause for a second while you go get yourself some graph paper. Okay, you got it? Good. Now, first thing I've got to do is look at my a value, which is negative 1. So this means my parabola is going downwards. I've got myself a mustache. Essential information. Next, we got to find our vertex. So to find the vertex, I'm going to find the x-coordinate by using handy formula, negative b over 2a. So x is equal to negative 6 over 2 times a, which is negative 1. Negative 6 divided by negative 2 is 3. This means that we have our axis of symmetry. It's just the vertical line x equals 3. Yeah. So why don't I just go ahead and graph that? Let's see, can I graph that? Yeah. I think I've got the skills to do it. I do have the skills necessary. Next, let's find the y-coordinate. So the y-coordinate we will find by just putting in 3 into the equation. Negative 3 squared. So the negative's on the outside there. Plus 6 times 3 plus 8. So I've got a negative 9 plus 18. That's a 9 plus 8 is 17. Which means the vertex is at, I was at 317. Yep, there we go. So we have that, we had this. Let's plot that point. So there's 3 and 17. This is fun. Okay, next we need our y-intercept. Y-intercept, piece of cake. It's just at 8. There's a dot on the graph at 8. Go ahead and reflect that across the axis of symmetry. It's 1, 2, 3 to the left, so I need to make a 1, 2, 3 to the right. Very nice. I already have 3 points. Let's just go ahead and find our x-intercepts. So to find the x-intercepts, we could factor that if it's factorable, or we could complete the square, or we could use the quadratic formula. Let's try that one. x is equal to negative b, which is negative 6 plus or minus square root b squared, or 36 minus 4 times negative 1 times 8, which is my c, all over 2 times a, negative 1. Let's just shortcut by putting this into the calculator. Yep. Huh, that's already in the calculator. Let's pretend like it's not and clear it. Okay. So I need parentheses around the whole top of this. Open my parentheses. Negative 6. Let's do the plus sign first. Plus the square root. 36 minus 4 times negative 1 times 8. Get out of the square root. Close the parentheses. Now divide it by 2a. That's 2 times negative 1. If you're going to leave it in the product like that and put it in the calculator being super lazy, you want parentheses around the bottom. If you don't want to put the parentheses, just type in whatever the product is. In this case, negative 2. Okay, so here's our first answer. Negative 1.1-ish. Which means that we picked a good choice for solving this by quadratic formula because we couldn't have done it by factoring. So x is equal to negative 1.1-ish. Negative 1.1-ish. Stop. Somewhere right in there. Okay, let's find the second one very easily. Just scrolling up here, changing this plus sign to a minus sign, like this, 7.1-ish. 7.1-ish. 5, 6, 7, 1-ish. Now here's the tough part. Connecting all these dots. I just have to find my pen. There it is. So let's see if I can pull this off. Ooh. Gosh, that's a good looking parabola. My oh my. Here, just take a look at this one instead. Let's see, there was the vertex and the axis of symmetry, the reflection of the y-intercept and the two x-intercepts, and yeah, that's what it's supposed to look like. Alright, the pen thing is hard. I'm going to give you a chance to graph a couple on your own. Hopefully your parabolas will look a little better than mine. So, try out these only 3 that are on here. This will be the last bit of information, the last bit of practice for this lesson, then we're done. Hopefully you got yourself some graph paper, graph those things, and then come back and we'll check our answers together. Did you have the skills? Were you successful graphing those quadratic equations when they were in standard form? Let's see how you did. So, here's your answers on the first one. First thing I wanted to do is look at the a value was 1. This parabola is facing upwards. I used my formula to find the vertex of that thing. X equals 2 over 2 times 1. It's 1. There's my axis of symmetry. And I go ahead and plug that back into the equation to get the y-coordinate. It's a negative 2. So I've got that part of my graph so far. My vertex at 1, negative 2, and my axis of symmetry. Okay, I can look at my equation. Y-intercept is negative 1, so I plot that point and reflect it across the axis of symmetry. It's 1 on either side. Okay, now I just need a couple more points. How about those x-intercepts? So use the quadratic formula here, math, and I get about 2.4 and negative 0.4. So graph those 2 points. And that should be enough to go and make myself a little parabola. Okay, let's check out this next one here. So a value is 2. It's going to open upwards. Another beard. Find the vertex. Negative 6 over 2 times a, 2 times 2. And it's negative 1.5. I just went ahead and left it as a decimal So I'm probably going to use the calculator to evaluate where the y-coordinate is anyway. And I did. And I get negative 1.5 comma negative 1.5. Let's graph both of those things. So I've got both my vertex and I've got my axis of symmetry there. And now my y-intercept is a 3. So I'm going to go ahead and graph that thing. Where is it? Where is it? Come on, there it is. A 3 and reflect it across. So in this one, it's 1.5 on the right side, so it's going to be 1.5 on the left side. Okay, and then find my x-intercepts using the quadratic formula and a little bit of math. And I get negative 0.6 and negative 2.4, like so, right there. There we go. Nice skinny parabola. Whoop. Last one. Let's take a look. Last one. Hey, what's going on? There we go. Last one. This one's negative. It's negative, so it's facing downwards. And look at that 1/3 that's there. 1/3 is closer to 0, so I should expect to get a fatter parabola. Okay. Find the vertex. Find the vertex. Its x-coordinate turns out to be, oh, yeah, let's take a look at this. This one had a fraction within a fraction. It's called a complex fraction. In a future unit, we will extensively examine those things. But for right now, if I think of this as a division problem, 5 divided by something, dividing by is the same thing as multiplying by a reciprocal. So I did 5 times the reciprocal of that, so negative 3/2. And clean that up, negative 7.5. Put that into the equation, and I get 20.75. So there's the vertex and axis of symmetry. Go ahead and put those up on the graph. Okay. And then y-intercept was 2. Plot that thing and flip it across the axis of symmetry. Use the quadratic formula, find my 2 x-intercepts. And with a little bit of math, I get negative 15.4 and negative 0.4. Negative. Ooh, yep, that's a wee bit of a mistake. I think this should have been positive. Right? So I could see it right there. Positive 0.4. Yeah, and now throw that graph in there. All right, let's just do like one more thing with this. Just one more. How about range? We know the domains for all of these are all real numbers, but what about the range? So my range here, maximum value is at 20.75. Just write this in interval notation. Range. Lowest, negative infinity. Highest, all the way 20.75. Close those brackets. Just go back to this one. Whoop, here. Back on this one. Okay, I've got myself a minimum value. So my range, smallest is, what number is that? Negative 1.5. Bracket negative 1.5 all the way up to infinity. Okay, one more. Right there. And the first one that you did, its range, lowest is negative 2, bracket negative 2, all the way up to positive infinity. Well, that was fun. Okay, so let's wrap this thing up. So we are talking about how to graph a quadratic equation whenever it's in standard form. And the things that I want to do are, I want to see if it is right side up or upside down, beard or mustache, and then I want to find the vertex, plot that thing in the axis of symmetry, find its intercepts, the y-intercept and the x-intercept, and usually that's enough points to go ahead and draw your graph. So that was objective 4.
Well, we covered completely in this lesson. We found the intercepts, x and the y-intercepts, the vertex, we have a handy little formula, negative b over 2a, and the axis of symmetry for a parabola. And number 2, determine what happens whenever you change the parameters on a quadratic equation. Specifically, that was a and c. A made it fatter and skinnier, made it right side up or upside down, whether it was positive or negative. And the c value was the y-intercept, and you change it. If you make it bigger, it moves up. Make it smaller, it moves down. Find the minimum and maximum value. Well, that is the y-coordinate of the vertex. So at this point here on this McDonald's, yeah, some more McDonald's for you. It's not that, I'm not trying to push McDonald's on you, because I'm not endorsing McDonald's. It's just parabolas, okay? Anyway, and then, yeah, we did some graphing. So
here's your assignment, and let me ask you to go ahead and bring in some graph paper for this assignment, because we're going to do a bit of graphing. All right, see you in class.